In an episode of Phineas and Ferb, Dr. Heinz Doofenshmirtz creates a machine that makes Candace, one of the characters in Phineas and Ferb, 10 times as big as he already was. Then he goes on to make the entire universe 10 times as big so that nobody notices a difference. Could this be done in real life? Could we make the entire universe 10 times as big as it already was without noticing a difference? Part of this video was recorded while I was sick, and another part was recorded after I got rid of the cold. So sorry if I sometimes sound a little bit weird. Before we start talking about if we could do it in real life, make the entire universe 10 times as big, we have to talk about how we would go about doing so. We could do this very simply. We could just add in the required mass and volume to make the object, in this case the entire universe, 10 times bigger. So for every molecule in Candace's body, we just add 9 more. But there are a few problems with that, and here they are. Well, first of all, we would have to do this to the entire universe. Everything would have to become 10 times as big. If you think that the universe is infinite, then this could work, because, well, just search up the mechanics of infinity. You can always take more if you have infinity. But if you think that the universe is limited and the contents within the universe are limited, then this doesn't work. Mass would always have to come from somewhere. So unless we take that mass from another dimension or another universe, we can't make the universe as 10 times as big. Your mass has been multiplied by 10. The Earth's mass has also been multiplied by 10. Now you might think that this leads to the gravitational pull being 10 times as strong. And you'd be wrong. It would be stronger, but not 10 times, because the distance between you and the core of the Earth has also increased. Not by 10 times, but a lot as well. So gravity would be stronger, but not 10 times as strong. So yeah, just bear that in mind. Second flaw, the square cube law. The square cube law states that an object's volume will always be less than an object's surface area. So say you have this square, right, or a cube, as this is called. It has the length of one diameter. It doesn't in real life, but let's just say it has. The length of one diameter, the width of one diameter, and the height of one diameter. This object then has a volume of 1 square diameter, or a liter. The surface area, on the other hand, would be much greater. The way we find surface area is to multiply the length by the width, so we find this one. We multiply the width by the height, so we find this one, and the height by the length, so we find this one, and we multiply those by 2 because we have 2 sets. And then we would find that the surface area of this cube, if it has a length, a width, and a height of 1 diameter, to be 6 square diameters. Now, if we were to take this cube and add 1 decimeter, see, 1 decimeter, every direction it increases more in height, in length, and in depth. Depth, man, I should have used that word before. Depth, not width. Width. So if we add 1 more decimeters in every direction, 1 more in width, 1 more in length, and 1 more in height, we find that the surface area is now 24 square decimeters, while the volume is only 8 cubic decimeters. The strength of your muscles, if you can even call these muscles, come from the mass of the muscles and not the surface area, meaning the larger you grow, if your size increases by many times, will weaken your muscles, and your muscles would not be able to keep your body arised. This also affects your heart. Your heart wouldn't be able to keep circulating your blood because, well, it just wouldn't be strong enough to handle that sort of height and that sort of length and strength. It just wouldn't do it. Let me show you an example. The tallest man to ever exist was 2.72 meters, I believe, and he became 22 years old. He died because his heart was not strong enough to keep the blood in his body circulating. I was going to talk about the third flaw, but it turned out not to be a flaw after all, and rather a big supporter of the scenario. So I thought that since the mass of the sun was multiplied by so many times and the mass of the earth was multiplied by so many times, they would just collide and the earth would be pulled into the sun. But it turns out not to be that, because, well, the distance between the earth and the sun has also increased, meaning that just all forces would be cancelled out. I mean, multiply the mass of the sun by 10, multiply the mass of the earth by 10 and the distance by 10, and everything just gets cancelled out. Nothing happens. Everything would just go on as normal. Gravity is a force that works between two objects, not just one. So while yes, the earth does pull you towards itself, you have to remember that you ever so slightly pull the earth towards yourself. This right here is the formula we use to calculate the force between those two objects, in this case the earth and the sun. We have force equals the gravitational constant times the first object, m1, times the second object, m2, divided by the distance between them, radius, squared. So here I have plugged into the numbers, and we have the gravitational constant, which is basically just a number that is there for everything to make sense. We have the mass of the sun, we have the mass of the earth, and the distance. And here I've done the exact same thing, except I have multiplied the mass and of the sun and the earth and the distance by 10. And if you run the numbers here, you come to the same conclusion. 3.45 times 10 to the power of 22 newtons, which is a lot of force. What these two calculations mean is that if you multiply the mass of objects and the distance between them by 10, the force that works between them, the gravity between them, is going to be the same anyways. Now you can calculate this yourself if you want to, but you are going to have a slightly different number because I used slightly longer numbers, like it wasn't 1.98, it was much longer than that. That whole mess is all taking into account that we add volume and mass. But what if we only add volume? What if we increase the distance between atoms by 15? Multiply the distance between atoms by 15. You know, like in Ant-Man. Well, we could sort of do that. I mean, the only thing that keeps atoms together is how charged they are. If an atom is less charged, it can allow its partner or its fellow atom, its connected atom, to be further away. But if it's a high charged atom, it must have the other atom very close. If we could somehow increase the distance between the atoms, or well, decrease the chargedness of the atoms so that they would drift further apart without turning into dust immediately, then yeah, that could work. Guys, I just want to say here that I am very, very uncertain about this topic, and I honestly don't know anything for sure. I mean, I could sort of see it happen, but then again, it doesn't seem like it could happen, and I'm sort of confused. So just know that I'm not entirely certain about the topic, and I might not be able to say that one thing can be done and one can't. I really am uncertain. So for the sake of argument, let's say you could increase or multiply the distance between atoms by 10, even though I am uncertain if it actually can be done. This would also mean that we increase all distances in the universe by 10. Multiply each distance by 10, obviously. Well, everything would become weird. Remember that calculation I just did on the whiteboard? Well, it relied a lot on distance and distance between objects. because you have the same mass as you always have, and the Earth has the same mass as it always have, but the radius between you and the Earth now has become a lot more. The gravitational pull between you and the Earth would be lower, meaning you could fly. Well, not exactly fly, but you could walk as though you were on the moon, more or less. Same would go for the Sun and the Earth, and the Sun and Jupiter, and the Sun and the black hole in the middle of our galaxy, and everything else in the universe that has mass. In fact, the Earth would now be moving so fast around the Sun that it would fall out of orbit, because it's moving so fast, and the distance between the Earth and the Sun has increased by so much. Here are a few other fun things that would happen in our scenario. Particle accelerators would stop working, because the atoms are in relationship to us now much smaller, meaning it would be much harder to collide them than they already are. In relation to us, the speed of light would be slower, speed of sound would be slower, Wi-Fi would be slower, like it wasn't slow enough already. Now, there are certainly more consequences. I mean, I don't know everything yet. My point is, if you have anything you would like to add to what I just said, before this clip, then let me know in the comment section, or if not for me, for other people, enlightened humanity, let us know. So if you have any corrections on me in this video, then correct me down below. I need to hear, because what we are trying to achieve here on this channel isn't for me to be smarter than everyone else. It's for me to come to the right conclusions, and if I'm not, you guys to correct me. That is our goal. So please correct me if you need to, if you think you need to. Yeah. To conclude, Dr. Heinz Doofenshmirtz, the doctor's machine would never work. Or it would just have a lot of consequences he didn't think about. Either way, it's not a good idea to make the universe 10 times as big as it already is. Before we take the element of the month, I would like to say that I can't give all my sources in this video. I usually do. I always link all my sources in the description, but some of this stuff is stuff I already know, and it's difficult to leave a source to simple stuff. Like knowing what mass and volume is, stuff like that. It's difficult for me to link a source to that, because I'm a big physics nerd. I do lots of research on this topic myself. So sorry if not all sources are down there. I mean, some of them are, many of them are in fact, but not all of them. Sorry. Don't forget to vote for your favorite element in the monthly element contest down in the comment section. Who knows, maybe your favorite element will be the next element of the month.